This is the tic-tac-toe playing machine. It can really play tic-tac-toe with you, and in this video I'll explain exactly how it works. At the start, the machine has already made a move in the center. Now I can choose between two counter moves. To play the other moves, I would have to rotate the machine. As you can see, any corner move is essentially the same move, just rotated. I make a move in the corner by pressing this key. You can see some movement going on inside the machine. We'll get to that later. Let's take a look at what happens on top first. As you can see, my move, the shield, and the machine's move, the swords, happen pretty much simultaneously. Now, to play the next move, I have to rotate the dial on the side. A lot of things happen, as you can see. The most important thing is that the brown plate at the bottom moved forward. That is the memory of the machine, which is now ready for the next move. Let's do one more move. Yep, that is the best response to that move. I'll finish this game later. It's time to see how this machine works inside. This is the core of the machine. It consists of 52 mechanical logic gates. Logic gates are the basic building blocks that make any digital electronic device work. The tic-tac-toe playing machine uses two types. It uses AND gates and OR gates. These are their symbols. They have simple functions. The AND gate's output is only true if all inputs are true, and the OR gate's output is true if at least one input is true. Now, instead of true and false, you could also say 1 and 0, or high and low. And high and low is spot on for this LEGO machine. In the tic-tac-toe playing machine, all logic signals travel upwards. The main reason is that this way gravity will take care of the default value of low, which makes the mechanics a lot simpler. So simple that a two-input OR gate can be built with precisely one part. This L-shaped part. Thank you, LEGO. If this part is pushed from below by any of the two axles, it will go up, which is a high output value. Gravity takes care of the reset if the input becomes low. Super simple yet very effective. The AND gates are a bit more difficult. This is one of the AND gates. It consists of two small subassemblies that can move like this. To show you how it works, I built a kind of cross-section model. You can see the one-piece OR gates at the top here, and the memory at the bottom here, which is read by these bars. We'll get to those in a sec. Now I put the first AND gate in here, and you will see it is dangling sideways. That is intentional. If I press the key now, nothing happens, which is correct because it is an AND gate and only one input is high. The memory input is still low, but we'll change that right away. When you turn the dial on the side of the machine, it lifts the memory readers so the memory can move, like this. Then when they are lowered, they read out the value of the memory. A golden plate is high. Now you can see that the memory reader has pushed the AND gate into position. Now, when I press the key, two things happen. First, this red thing goes up, and second, the axle at the top goes up, which is our L-shaped OR gate that also went into action. Its purpose is to trigger the shield corresponding with the key. Thanks to the AND gate, that will only happen if the move is valid. Let's move on to this red thing. That's actually another OR gate, but this one has 8 inputs and is almost as wide as the entire machine is. What it does is carry the signal sideways to all the AND gates controlling the swords. I'll put one on the machine and show you how that works. Now the AND gate controlling the swords combines a bit red from the memory with the red bar. If both are true, the output is high and this again goes into an OR gate, but this one is triggering swords. Now we are halfway there. See, with this setup the machine can support one response at a time. But to play a game, we need to support at least 2 responses at the same time. That's where this blue thing comes in. It's a second 8-input OR gate that isn't triggering or responding to the AND gates we have used so far. It works with a second set of AND gates, these. Same principle, but slightly different. Now I modified the program a bit to show you what happens. First up, all memory readers low. Nothing happens. Now the new additions. This time the blue bar goes up. The OR gates at the top make sure the shield and swords are triggered. Now back to the first set. Both active. Everything still works. The blue OR gate does not move. The red one does, and both shields and swords are still triggered via the OR gates on top. This entire thing is the complete set of logic gates for one field. The tic-tac-toe machine has this combination 8 times, and it uses 2 more AND gates to control program addressing. That's why all the AND gates are one stud wide, otherwise it wouldn't fit. Now let's quickly see how the machine can play an entire game of tic-tac-toe even though it can only have 2 responses in each of the 6 program steps. In the first step, the player can make the 2 moves I've highlighted. Remember that all the other moves are just rotations, so therefore we only support the 2 moves. So we stay within the limit of 2 responses in this step. I started the game with the top move in the corner. When I pressed the key, the arm in the right side dropped. It blocks the memory when the dial is turned. The memory moved quite a bit and jumped over 2 program steps. If I had played the other move, the arm on the left would have dropped, which always stops at the next step in the program. The game could have arrived at these 2 steps at this point. I highlighted all the player moves and the responses of the machine. As you can see, there's just 2 responses, even though there are many more player moves. That's because the machine will always make the winning move if the player didn't block it. When the game is over, the arms will not drop, meaning the program is not blocked and moves to the end of the program when the dial is turned. Here's the complete overview of all steps in the game plan. As you can see, there's just 2 responses in every step. I made a spreadsheet to translate this game plan to the program memory. This makes sure every bit ends up in the correct position. Now, let's finish the game and see all this theory in action. I made the bottom move at step 4 and we're now at step 5. I need to avoid the machine getting the horizontal 3 in a row and make the bottom move. The machine responds as predicted and the left arm drops to stop the memory at step 6. Now the bottom move is the losing move and the top one will end in a draw, which I consider a win. So I'll make that move and the machine will play the top left corner. And that's the end of this game and also the end of this video. This project is on LEGO Ideas. You'll find more information there and you can give the tic-tac-toe playing machine a chance of becoming a real LEGO set by supporting this project on LEGO Ideas. Thanks for watching!